dear students, welcome back to my channel. My name is Part-3 and thank you so much for being such an amazing audience so far. We have successfully crossed more than 350 subscribers in just 10 days. So in today's session, we are gonna cover the third part of acids, bases and salts, and in today's session, we will start with bases. So let's get started. Alright students, let's start with the third part of acids, bases and salts. In this part, we will discuss basic introduction and some preparation methods for bases. Now, let's understand bases. So bases you would have studied in junior classes. How do we generally describe bases? So bases are those compounds which when dissolved in water will give us OH negative ions as the only negatively charged ions. So if we look at that definition, so we can say in general, bases are compounds which when dissolved in water will give us OH negative ions. Okay, now what kind of example can we have here? Let's say we can have NaOH, we can have aluminium, so AlOH whole thrice, we can have calcium, that is CaOH whole twice. So these are certain examples of bases that we can have, and if we dissolve water in these, what do we get? For NaOH, what we will get is, we'll get Na plus OH negative ions. For aluminium, we'll get Al3 plus OH negative ions. For calcium, we'll get Ca2 plus OH negative ions. Okay, so this is what bases are generally what we have studied so far. Now let's go into further detail of this. Now if we take a look at this, our bases generally are attached with a metal. We have sodium, we had aluminium, we have calcium. So these are certain metals that we have attached with. Now what happens is that it's not necessary that you always have a metal, because we have an exceptional case here. The exceptional case is ammonium hydroxide. So in general, we always have a metal attached with the OH negative ion in a base except ammonium hydroxide. So let's look at that. Bases generally have a metal attached with OH negative ion except ammonium hydroxide. Let's look at the equation for that. I have NH4OH and I add water to it. I'll get NH4 plus OH negative ions. Okay, so this is a base, but this does not have a metal attached with the hydroxide ion. Now, this was the general basic definition that you have studied so far. Now let's look at what is your 10th grade ICSE definition, because it has to get upgraded. So the upgraded definition for you is, a base is either a metallic oxide can be CuO, or a metallic hydroxide or ammonium hydroxide, which reacts with acid to form salt and water only. Now what are our keywords here? The keywords are metallic oxide, metallic hydroxide, and of course ammonium hydroxide is an exception, so we will pick that in the definition. Or ammonium hydroxide, which reacts with acid to give you salt and water only. Only is the most important keyword here. Okay, you cannot skip only. Now take a note of this definition and we move on. And let's look at a few examples. Metallic oxide, CuO plus HCl. What will that give me? That will give me CuCl2 plus water. MgOH whole twice plus HCl will give me MgCl2 plus H2O. I have NH4OH plus HCl, that will give me NH4Cl plus water. Okay, now what is the importance of the word only? Okay, so we do have a metallic oxide which when reacts with an acid, it gives you salt, water, and it also gives you chlorine gas. So that particular metallic oxide will not be considered a base. So let's look at that example. What is the importance of the word only? So PbO2, that is lead oxide, very important exception. Lead oxide, when it reacts with HCl, it will give you PbCl2 plus water plus chlorine gas. So this is the reason why the word only is important, because PbO2 is not a base, because along with salt plus water we have a third product coming out, that is chlorine gas. So you can take a note of this, my dear students. PbO2 is a metallic oxide but not a base, since it also forms chlorine gas along with salt and water when reacted with an acid. Okay, I hope you are able to understand so far. So we have done two exceptions so far. One exception is that all bases have a metal attached with them except ammonium hydroxide. All bases will give you salt and water only. PbO2 is an exception there because PbO2 is not a base. Why is that? That is because along with salt and water it also produces chlorine gas. So I hope everything is clear so far. Okay students, moving on to alkalis. Now what are alkalis? Alkalis are those bases which are soluble in water and which will give you OH negative ions as the only negatively charged ions. Okay, so what does that mean? That means that not all bases are soluble in water. The bases which are soluble in water are called alkalis, but not all bases are soluble in water. So what are alkalis? Alkalis are bases which are soluble in water and which will give you OH negative ions as the only negative charged ions. Only negative ions. Okay, what are alkalis again? Bases which are soluble in water and gives you OH negative ions as the only negatively charged ions. So let's look at the definition. Bases which are soluble in water and produce OH negative ions as the only negatively charged ions dissolved in water are called alkalis. Okay, now when we have alkalis, you can take a few examples. Let's say we have NaOH. So NaOH, when dissolved in water, it will give you Na plus OH negative ions. Other example can be your let's say CaOH whole twice, when dissolved in water will give you Ca plus OH negative ions. Okay, so these are some of the alkalis. That means these are bases which are soluble in water. Now there are certain common names that you should remember. That is, NaOH is called caustic soda, KOH is called as caustic potash. Then we have CaOH whole twice, which is known as slaked lime. Now one extra thing to remember here is that your slaked lime, if added to water, it will give you lime water. But this particular reaction is exothermic in nature. Okay, so slaked lime can be dissolved in water to give you lime water, but that is an exothermic reaction. Okay, now another thing to remember is that NaOH and KOH are strong alkalis. That means when dissolved in water will give you high number of OH negative ions, whereas your slaked lime and NH4OH, ammonium hydroxide, are weak alkalis. That means when I dissolve these in water, I get low number of OH negative ions. So I hope this much is clear. What are alkalis? The definition and a few examples. Now, what kind of question do you get in the reasoning? Which of these statements is true? Are all alkalis bases or are all bases alkalis? So which one is true? You can pause the video right here, write your answer, and then continue to check if you are correct. Okay, let's check the answer now. Which of these statements is true? So the first statement is true. That is, all alkalis are bases. What does that mean? That means that alkalis is what? Alkalis is a base soluble in water. But as I mentioned, not all bases are soluble in water. Therefore, we'll say all alkalis are bases is true. Example in the explanation that you can mention is ferric hydroxide and copper hydroxide are bases which are not alkalis because they are insoluble in water. Extremely important to remember. All bases are not soluble in water, therefore all bases are not alkalis. So FeOH whole thrice, that is ferric hydroxide and copper hydroxide are bases which are not soluble in water. Now, moving on to classification of bases. So we have a strong base and we have a weak base. Now since we are checking the strength and we are mixing them in water, so we can also say that strong alkalis or weak alkalis. Because if it is not soluble in water, we do not know how to get the strength of it. So what would happen is, strong bases or strong alkalis are the ones which when dissolved in water gives high number of OH negative ions, and in this case you get low number of OH negative ions when dissolved in water. So you add water on both the sides, and on strong alkalis you will get a very huge number of OH negative ions. On weak alkalis you will get a pretty low number of OH negative ions. This we have also discussed strength when we were doing acids. So what happens is that let's say you have 10 molecules of a strong alkali or a strong base, and what happens is out of 10 molecules all of them ionizes. So when you have all of them getting ionized, so minimum you will get OH, like all of them as OH negative ions. Using 10 molecules gives you 10 ions of OH negative. That is a strong alkali. What would happen in a weak alkali? Let's say you have 10 molecules of the alkali being dissolved in water. Only 4 or 5 of them will give you ions, and others will stay as molecules. So in strong bases or strong alkalis, you will have ions in the solution, and on this side you will have ions plus molecules in the solution. Let's look at a couple of examples. So for this one, your examples would be NaOH and KOH, because we already discussed they are strong alkalis. And on weak alkalis, you will have ammonium hydroxide, NH4OH, and slag lime, that is CaOH whole twice. So now you can take a note of this definition which is properly written here. That is, bases which when dissolved in water produces a large number of OH negative ions are called strong bases. NaOH, KOH, and then you can give an equation for that. Bases which when dissolved in water produces a less number of OH negative ions are called weak bases or weak alkalis. Okay, then you can take a note of these examples right here. So moving on to the second classification of bases, that is depending upon their acidity. So we also did, when we were doing the classification of acids, we did depending upon their basicity. So what did that mean? That meant that when you have one molecule of acid, you dissolve it in water, how many molecules of H plus ion, how many ions of H plus do you get out of it? So similarly, when we talk about acidity of a base, that means when you dissolve one molecule of the base in water, how many OH negative ions do you get out of that? So that defines your acidity. That means one molecule of base plus water, how many OH negative ions do I get, will define my acidity of the base. So let's look at the definition for that. So acidity of a base is defined as the number of hydroxide ions produced when one molecule of base is dissolved in water. Now let's look at a few examples, few types on this. So I have monoacidic base. Mono means one. That means when I dissolve one molecule of this base, I get one OH negative ion. So let's look at the example. I have NaOH, which will give me Na plus OH negative ions when I add water to that. Then I have diabasic base. That means I have 2. Acidity is 2. That means when you dissolve this particular base in water, you get 2 ions of OH negative. So let's look at an example. I have CaOH whole twice, that is slaked lime, plus water, which will give me Ca2 plus 2 ions of OH negative. So this is diacidic base. Moving on to triacidic base. So you can have AlOH whole thrice, which when dissolved in water will give me aluminium 3 plus 3 ions of OH negative. So this is a triacidic base. Now these are the bases which are soluble in water. We also discussed there were 2 bases which were insoluble in water and non-alkalis. So what were those? Pause right here, try to think of the answer and put it in the comment section. Okay, now moving on. Now let's see what were those. You can check your answers. Those were your ferric hydroxide and cupric hydroxide. So for water insoluble bases, acidity is equal to the number of replaceable or hydroxide ions in one molecule of that base. That means if I think about ferric hydroxide, this has 3 replaceable of hydroxide ions. So the acidity for ferric hydroxide would be 3. Similarly, for cupric hydroxide, I have 2 replaceable hydroxide ions. This means that acidity would be 2. Okay. Now, moving on, this is where we finish classification of acids. From here, we move on to preparation of classification of bases. From here on, we move on to preparation of bases. So we have in total 6 methods of preparation. We would be working on 3 in this part and we'll start with 3 in the next part. So the first preparation of base is from metals. So method 1, metals when react with oxygen gives bases. That means sodium plus oxygen will give me Na2O, that is a base. Magnesium plus oxygen will give me MgO, that is again a base. Moving on to method number 2, by the action of water on active metals like sodium, potassium and calcium. So you have metals, they combine with water and they give you metallic oxides or metallic hydroxides. So metallic oxides you got right here. This will give us metallic hydroxides. So Na plus H2O will give me NaOH plus hydrogen gas. K plus H2O will give me KOH plus hydrogen gas. Calcium plus water will give me slaked lime, that is CaOH whole twice plus hydrogen gas. So what have we understood so far? I have a metal combined with oxygen will get metallic oxide. I have a metal combined with water, I get metallic hydroxide. The third one would be I have a metallic oxide, I combine that with water. What do I get in this case? So go ahead and try these equations. You can pause the video right here and give this a try. Okay, so when I have metallic oxide and I combine that with water, I'll get a base. What kind of base will I get? I'll get NaOH. Then I have K2O plus water, that will give me KOH. CaO plus water will give me CaOH whole twice. So what is happening? We have got a pattern again. Metal plus oxygen, metallic oxide. Metal plus water, metallic oxide, metallic hydroxide plus hydrogen gas. Third one, metallic oxide plus water will give me base. You will not get, so no hydrogen gas here. You have to remember that. Alright students, so this is where we end today's session. Thank you so much for staying connected till the end of it. In the next class, we would be working on the preparation of bases and physical and chemical properties of bases. Thank you so much for all your love and support. I highly appreciate it. So keep moving forward. Let me know in the comment section if you have any concerns or doubts, and we'll catch up in the next session. Thank you.